Question number 2. Two balls P and Q are projected from the edge at the edge of a cliff. P is projected horizontally with speed v, and Q is projected vertically upwards with the same speed. I am standing at a cliff here. Okay, there is one ball which is thrown from here vertically. It has been projected upwards. What is this called as? P is projected horizontally with speed v. So this is called as P. This is called as P, and this will now describe a projectile motion like this. Okay, so therefore this initial velocity was v here, and then Q is projected vertically upwards at the same speed. Now there is one more ball over here which is being thrown upward like this. What will happen to this ball? This ball will go upwards and then come and fall here. Okay, now we have got both this one. The time taken for P to reach the ground is Tp. So this is the Tp, time taken by it to reach this Tp. Good. So and the speed at the impact with the ground is Vp. Here it is Vp. Here resistance is negligible. Good. What is the time speed taken to reach the speed and the speed at impact with the ground for Q? So how much time will this one take, and compare this with this time? That's the question. Now logically speaking, we definitely know this will take a longer time to go to the top and again come back. But we need to prove it logically. Okay, so how do we prove this? This is a question over here. So how do we prove? So what we do is we can say something like, we can apply my equations of motion. Let me consider this is my origin. This is my origin. So this should be minus h over here, right? This is minus h. So as a result of it, I will now write it over here. I'll write a minus h is equal to, for the first one, I'll write minus h is equal to, so since the particle is thrown upwards for v, so p, so it will write a vt plus half into, what's the value of a? Minus g into p square, right? So therefore this should now become, I'll write h is equal to vt minus, this is negative, this also negative goes away, I'll write minus vt plus half gt square. I'm doing it only for p. Okay, I'm not done for q. I'm doing it only for p. So therefore I'll take this minus vt on the other side. I'll get h plus vt is equal to half g tp square. I have got this value so much. Now similarly, I don't have space. I'll write it over here. Okay. Now similarly, I'll do the same thing. Okay, I'll do it here because I want this one for velocity. I'll do the same thing for the q also. Okay. Now how is q thrown? Sorry, this is P is projected horizontally, right? Okay. So this is for q. I'm sorry. This is for q. Okay. And for P we will do it now. For P, what do? We throw it like this over here. So therefore, once again, I have minus h is equal to then your vertical velocity. Vertical velocity is 0 because I'm throwing it horizontally. So this should be 0. Okay. Plus half into minus g p square. What is this now? Tp square over here. In other words, half gtp square is equal to just h. Now you see, half gtp square is equal to h, half g2q square is equal to h plus vt, which means this factor is larger here, okay, as compared to this factor over here, right? Because if let us say, for example, if h is equal to some 5 meters over here, so this would just be 5 here. So this will just be 5. What will this value be? Will this be negative? This is not negative. V is a speed over here. T is time. T is also not negative. So let us say, for example, even if this is 1 unit over here, 5 plus 1 becomes 6 unit here, and here it becomes only 5 unit over here. So as a result of it, what will happen? If this is larger, PQ is also larger, right? So therefore, you can now say PQ is larger than PP. So which answers will be right? These two would be right. So these two are incorrect. Okay, let us eliminate all the non-possible outcomes. Now, the next one, speed at impact. Now, how do you do with speed at impact? Now, when you throw this particle here, what is the energy here? Use energy conservation. Okay, so therefore, when you throw the particle, what's the energy here? The energy here at this point is nothing but half mvp square. I'm doing it for the for the particle p, half mvp square plus mgh because the particle is at a height here. Okay, should now be equal to, when it comes over here, what is the height? Height is 0. So as a result of it, this should be half mv dash p square, because the velocity is higher, right? And what is the potentiality? 0. So total initial energy is equal to total final energy. I have done it for the particle p over here. Now let us do it for pq also. So what do I get here? Half mv. So when I throw it here, what was the velocity here? once again the same velocity Vp square. And what was the potential energy? Potential energy at this point, I'm not talking about this point, okay? Potential energy at that point is nothing but mgh is equal to, when it came down over here, it came at some velocity over here, which is nothing but a half mv. I do not know what is that velocity. I'll write half mv q dash square. This is for q. Now, as you see here, on the left hand side, half mvp square plus mgh is same for both the particles, right? So, as a result of it, right hand sides we can equate it, or in other words, I can write half mvp dash square is equal to half mvq dash square. So, half m goes away. So, you have vp dash is equal to vq dash, which means what? The speeds of both the particles at the ground, whether you throw it horizontally or you throw it vertically upwards with the same velocity, will be the same. Okay, so that's what is the right answer here. It should be Vp only. So thus the answer is C here. Answer is C because I have written something here and marking it out. Okay.